Hey there. Today, I'm going to be looking at a piece of 1980s computer nostalgia. I have with me a TRS-80 MC-10 microcomputer, complete with the 16K expansion pack, and the tape drive. Now, when I bought this unit, I discovered something that I think makes it very unique. So today, we're going to take it apart, give it a little bit of a cleaning on the inside, and take a look at what I feel makes this such a unique unit. All right, let's go do that. The TRS-80 MC-10 computer is an entry-level computer released by Tandy and sold in Radio Shacks in 1983. It retailed for a price of $119.95 US and was intended as a low-cost alternative to the rest of the TRS-80 line and to compete with other entry-level computers, such as the Commodore VIC-20 and the Spectrum ZX81. It was released with 4K RAM and had 8K ROM for the operating system, Microcolor Basic. The RAM was expandable to 20K with a 16K memory expansion pack that plugged into the edge connector in the back. The computer also had a built-in RF modulator, so it could be used on any TV set. No special monitor required. There was also a cassette port for storage, and an uncommon feature for computers of its range was that it had an RS-232 serial port that could be used for line printers or modems without the need for additional hardware. Unfortunately, the edge connector had an unusual number of pins, which made connectors hard to find, and the serial port had very limited usefulness. This, coupled with the undersized, uncomfortable chiclet keyboard and the lack of software available, led to the discontinuation of the MC-10 in 1984. There was, however, a collaboration between Tandy, Matra, and Hachette that allowed the MC-10 to be released in France under the name Alice. This version did find some success, due to it finding its way into schools under the Information Technology for Everyone program. The Alice had two successors, the Alice 32 in 1984 and the Alice 90 in 1985. The MC-10 has become a popular computer lately with hobbyists to test themselves to see just what can be done with this very limited 1980s piece of computing history. And here's my MC-10 all hooked up. Now there are some very interesting things about this computer that I want to look into. As I stated earlier, the MC-10 came with 4K of memory, which means when you check the available memory after turning it on, there should be about 3,200 bytes free. But with this unit, there's 7,238, which means this has 8K of RAM in it rather than 4K, which wasn't available, which means somebody's modified this. Now, due to the fact that this has been modified, when you add the 16K memory expansion pack, it does some very interesting things also, which I'll show you right now. Just turn it off. Plug the expansion pack in. Back on. Now you can see that gets a little bit of interference with the expansion pack in there. And also, when you check the available memory, now there's 8K on board here. And the 16K expansion pack, it should have 22K of memory. But there's 19,526 bytes free, which means there's only 20K. Which means it's only actually reading the first 4K of available RAM in here. And as you can see the interference on the screen here, when you run a program, it also, the interference gets a lot worse. I'm going to show you 3 programs here. One that would run on the initial 4K memory, one that you need the expansion pack for, and one that's in machine language that is loaded directly into the memory. They all act a little bit differently, so I'll just set that up and show you what's going on. I've unhooked the expansion pack, so we're back to the original, well, actually 8K of memory. So the first thing I'm going to do is load a smaller game into it, one that I just typed in off the internet. And this one is called Freeway. It's a fairly small program, simple. You're just moving a block across the freeway and trying to avoid cars. And it's done, loaded. As you can see, it's not that long, not all that much fun to type in on a chiclet keyboard like this, but you know, I got through it. Now, here it is. So as you can see, looks nice. There's no interference. Here's the green dot. You just get across. There we go. You score points by getting across. You lose points if you get hit by a car. Okay, that's this game. Now I'll set up to load a larger game that I need the expansion pack for. And here we are ready with the 16K expansion pack hooked up again. So we've got the 19,526 bytes free. So let's load this game in. Now you can see it gets a lot more interference when you're doing this. Now see, this is a version of Minesweeper, which when you think about it is pretty neat to be able to run on a computer like this. Now it's not a particularly long program, but it uses a lot of memory to run. So really not that long. Not actually, I think even a little shorter than the one that worked in the 4K memory or the 8K. But as I said, to do all the computations and stuff of figuring everything out, it uses a lot more memory. So we'll load a medium game. This takes a little while, so we'll just speed this up. And here we are. So you've got the grid. Just move around, pick a square, and you get the same numbers as you do with the other one. Eventually you'll find an empty spot. That didn't work. Okay, well, anyways, you can see the interference. And because it's using a lot more memory to map all this out, remember where all the mines are. So now we will hook up a machine code language game that loads directly into the memory of this machine. And we're ready to load the machine language program straight into the memory. Now, as you can see, what I've done is I just have hooked the cassette cable straight into the headphone output of my iPad. And now you have to type cload M to because it's to load it directly into the memory. And it's a Pacman game. I've played this on the emulators, and it's really fun. So, but it takes a little bit to load up, so I'll just speed this up a bit. All right, it's done. Now, because it's an executable program rather than a runnable program, because as you can see, it didn't actually load anything into the memory or into there, so there's nothing to look at. It's all in the memory, so you have to execute it rather than run it. And unfortunately, none of these lines should be here. It should be showing you the names of all of the ghosts and everything else. And here we start it. And you can see the interference is way worse now. Unfortunately, yeah, I think this would be a great game to play if this interference wasn't so bad, but unfortunately it is. So it clears up nicely and just gets a few lines on it when you die, but you know, it's because that's using so much of the memory right now. I think it's just causing some sort of interference. So I guess we're going to open this up and take a look and see if we can figure out what's going on inside. So I'm going to stop the video here before it gets too long. But join me next time when we find out exactly what I found inside this machine when I took it apart. Remember, a like and subscribe would be greatly appreciated. Don't forget to leave a comment below. And if you didn't enjoy this, give me a thumbs down. Alright, see you next time.